This is Geometry B, Unit 6, Surface Area and Volume, Lesson 2, Surface Areas of Prisms and Cylinders. First thing we need to define is what surface area means. There are two quantities we're going to measure when it comes to three-dimensional objects. They are surface area and volume. Surface area is the area of covering. So how much paint you would need to paint a three-dimensional object, how much wrapping paper you'd need to wrap a gift. That would be surface area. How much material it needs to go into making a box. Volume is the space of filling. Okay, it is how much room something takes up. We measure it in cubic units. Area of covering is measured in units squared. Area of space of filling is measured in units cubed. We're talking about squares for covering. We're talking about cubes for filling three-dimensional objects. Okay, 2D objects for covering and 3D objects for filling. You can think of sugar cubes, or for area, you can think of 1 unit square stickers that you're covering over the object with. Okay, and the next thing we need to define is a prism. A prism is defined as any shape. It can be literally any shape pulled through space. So let's say this is a shape, and we're going to pull it through space. So we're going to pull it through space so it does this. Okay? And that then is a prism. Now if you look at the shape in the background, right? The shape in the background is the same as the shape in the foreground. Shouldn't have done something so oblique. Okay, so there's this shape in the background that matches the shape in the foreground. And that's called the base. Let me draw one oriented vertically. So let's say we've got a rectangular prism. It has two bases, the top area and the bottom area. Those are called the bases. And the distance between the base, perpendicular distance, is called the height. Okay. Now, if you've ever taken apart a box, like a cereal box or a container, a package that holds something, you know that it expands into a 2D shape. We call that a surface net. We learned that in Unit 1. But let's do this here. Let's take the top and the bottom, which are two rectangles, the bases, and let's take the lateral area, or the side area, lateral area. The lateral area can be thought of as a series of rectangles connected, in this case, to form one large rectangle. Okay? And if we think of this as the area, as the perimeter of the base as being the distance around the base, okay, then that perimeter becomes the length of our rectangle. That becomes the length of our rectangle, and the height of our rectangle is here. So the area of that rectangle is perimeter times height. Okay, and the area of the base we're just going to call B. So the formula for the total area is 2 times the base plus the perimeter times the height. And that's the formula for the surface area of any prism whatsoever. Okay? Let me give you an example. Let's say I've got an irregular shape. kind of a bean shape here. And I tell you the area of the base is 40 square centimeters. And the perimeter of the base is 20 centimeters. And the height is 8 centimeters. Then the surface area becomes 2 times 40 plus 20 times 8. 2 times 40 is 80. 20 times 8 is 160. 160 and 80 is 240 square units. Okay, so that's how you would use the formula. When it comes to a rectangular prism, you probably have been taught in middle school that you can use this formula where we have length, width, and height. Length, width, and height. And you can use surface area is, let's put it down here. Surface area is 2 times length, width, plus 2 times width, height, plus 2 times length, height. Okay? But this also works as well. If we take the area of the base is going to be length, width. Length, width. Okay? So our new formula, the surface area, is 2 times the base plus the perimeter times the height. The surface area is 2 times the base is length, width. The perimeter is length plus width times 2. 2 length plus 2 width. 2 length plus 2 width. That's the perimeter. And times the height. And if we distribute the height, we get, look at this, 2 length width plus 2 length height plus 2 width height. We get the same formula. The order is a little bit different, but order of addition doesn't matter. Okay? So just so you know, it does work. If you want to use the old formula for a rectangular prism, that's perfectly fine. Okay? And then we have, that's a prism, and then this lesson is also going to talk about a cylinder. Okay? A cylinder basically is like a prism, only it has a circular top and bottom. Okay? So let's define our perimeter this way here, or our cylinder this way. So our cylinder looks like this, and use a dotted line for hidden edges. Okay. And it really follows that this has the same formula for the surface area as a prism does. It's just that it doesn't have straight sides. So you can think of the surface area as 2 times the base, the area of the base, plus the perimeter times the height. Okay? But the base, the area of the base is just a circle. And the area of a circle is pi r squared. So the 2b is 2 pi r squared. And the perimeter is just the circumference. The circumference of a circle is 2 pi r. So perimeter is 2 pi r times the height. And so there's our formula for the cylinder. The surface area of a cylinder is 2 pi r squared plus 2 pi r h. Do note what these are. It's important to understand what these are. Pi r squared is a circle. 2 pi r is the circumference of a circle. Okay? And when we do 2 pi r h, we're doing just the lateral area. And it's important to recognize that when you take apart a can, you have 2 circles and a rectangle. 2 circles and a rectangle, where this is the circumference of the circle and this is the height of the can. Okay, and this is the radius. So we have the radius and the height, and with the radius and the height, we can find the surface area of the can, of the cylinder. All right, that's it.